Hi, my name is Pablo Sanchez, and this is CDA3201C Lab 1. Here I am demonstrating the lab that I pretty much built the circuit. And now we're going to test the circuit, make sure I plugged in everything correctly into the gates, which are in the chips. And we have a truth table just to prove that. So there are two of the same equivalence Boolean functions that we have that we're going to implement. And there are only, let me see, 1, 2, 3, 4, 5, 6, 7 out of the 16 possibilities that the lights will glow. I plug in one of the equation, which I believe it is, let me read this. Let me read the circuits really quick so I can determine which Boolean expression. Yes, A D naught or BC is connected into this LED, and B and C or A B naught D naught or A C naught D naught is connected into this LED right here. So if I test it out correctly, they should both light up at the same time when they're when the function is true, when the expression is true. So we are going to test it out with each individual one, and we're going to start with 0, 0, 0, 0. And I'll say it out loud so you can hear me as I demonstrate. So let's turn this on. And further explanation, we have our dip switch. 1 is connected to A, 2 is connected to B, 3 is connected to C, and 4 is connected to D. So we have the first, they would say, kind of actually can't remember what's the terminology for it, but we have the first input, which is 0, 0, 0, 0, and we have no lights. So let's try the second one, 0, 0, 0, 1, and we would switch D on. As we switch D on, we see that still there is no LED lights going on. So none of the expressions are true yet. None of the Boolean expressions, Boolean functions are true yet. So our next one is 0, 0, 0, 1, 0. So that means C would be 1, and the rest would be 0. Still nothing, so our truth table is proven correct. And our next one is 0, 0, 1, 1. So that means C and D are both on 1. Still nothing at all. Alright, so our next one is 0, 1, 0, 0. So let's turn these off. Let's turn C and D off, and for that, we only have B that is on. Let me not disconnect the dip switch itself. Make sure it's in there. So we have 0, 1, 0, 0. Okay, still nothing on, so that proves to be correct. So now our next one is 0, 1, 0, 1. So let's turn on D. So we have the input 0, 1, 0, 1, but still our output is 0. So our next input would be 0, 1, 1, 0. So we turn off D. We set C to 1. So we notice when we set B and C to 1, as we read the as the input is 0, 1, 1, 0, both the lights go on, which is in fact true. 0, 1, 1, 0 is one of our 7 out of 16 in which both the Boolean expressions, Boolean functions, are true or equal to 1. So that proves well. So our next one is 0, 1, 1, 1. So let's turn on D, and hopefully these lights will stay on, and thus they do. The lights definitely do stay on, as we have 0, 1, 1, 1. Everything's going right. So now we have an interesting one. So we have 1, 0, 0, 0 as our next input. So I'll turn these off, and that means A is only true. So A, let me not disconnect the dip switch again. A is true and the rest are 0. So yet again, it shows that the function for both of them, as they are both equivalent, is true, and the lights will come on. So let's go to the next one, which is 1, 0, 0, 1. So A is true, B and C are not true, and D is true. So we switch on D, we notice that the lights go off, meaning that the function, both expressions, are not true, which it does match our truth table, so it's awesome. So I did the truth table right, now I also did the circuit right. So this is going very well. So our next input is 1, 0, 1, 0. This means A and C are on, but D is off. B and D are off. So let's switch that really quick. There we go. The lights turn on, matches the truth table. On to the next input. The next input is 1, 0, 1, 1. So A, C, and D are on, and B is off. And yet again, it matches our truth table. The function is not true. So we have our next input, which is 1, 1, 0, 0. So A and B are true, and C and D are off. And this matches our truth table yet again. The function is true when A and B are true and C and D are not true. So let's try our next one, which is 1, 1, 0, 1. So that means A, B, and D are on and C are off. And yet again, this matches our truth table. Awesome. We have 2 more to go and we should be good to go. So 1, 1, 1, 0. 1, 1, 1, 0. So that means A, B, and C are on, but D is off. A, B, and C are true, and D is not true. So we get both LEDs on yet again, and that's awesome. And then for the final one, we have 1, 1, 1, 1, meaning all A, B, C, and D are true. And let's see what we get. Awesome. The lights are still on, the function is true, matches the truth table. This is a success. A bit of a mess, but definitely a success of building the circuit and also proving that these two Boolean expressions are equivalent to one another, which also denotes the fact that when you simplify a Boolean expression or Boolean function, there could be multiple answers, but they lead to the same result shown in the circuit. Thank you so much for watching. Bye, everyone.